So this is lesson 3 in our decimals topic, and today we're specifically going to talk about converting fractions to decimals. Now, I have an order here of things to talk about, but I'm going to change the order and first talk about when our fraction has a denominator of 10 or 100, okay, for those fractions there. Now, if a fraction has a denominator of 10, then the decimal will have one place after the decimal point. One decimal place after the decimal point. If it's a denominator of 100, then there'll be two places after the decimal point. Okay, very simply. And then we are just writing the numerator as the decimal part. So for example, if I had 3 over 10, that would be 0.3. Now if I had 33 over 10, now we all know that is a improper fraction. So how would we deal with that? Well, I would probably deal with it this way. I would write it as a mixed number first. So 10s into 33 go 3 times, with 3 left over, so it's 3 over 10. So that means our decimal will have a whole part of 3 and a fraction or a decimal part of 0.3. Not 0.3, just 0.3. So the answer would be 3.3. Now, if it's 100, well, if I had 16 over 100, very simply, we have to have two numbers after the decimal place because it's out of 100. So the answer would be 0.16. But if it was 3 over 100, we're still required two places after the decimal point, but we only have one number. So what we do is we fill in the rest of the places with zeros. So we have to have 3. We can't have 0.30 because that would be like having 30. We actually need 3. Alright, so that would be wrong. Alright, so that deals with new denominators where we've got 10, 100, 1,000 and so on. Okay? Now, the other decimals that you really need to know, okay, and really need to know without too much calculations are these ones. We need to know what 0.25 is, 0.5 and 0.75. Now I know that we can write them as 25 over 100, and we can write this one as 75 over 100, but we need to know what the simplified fractions of those are. 0.5 is easy because it's basically a half. Okay. 0.25, well, if you think of 0.5 as 0.5 with a 0 in the end, so it looks like 50, 25 would be half of 50. So that means this fraction here would be a half of a half, and a half of a half is obviously a quarter. Now 0.25 is a quarter, 0.5 is a half, then 0.75 is, you can see that it is 3 times 0.25, so it would be 3 quarters. Those you should know in an instant without working them out. So if you see a decimal with a 0.25 or a 0.75, you know it's a 3 quarters or a quarter, and if you see a 0.5, you know it's a half. Okay, so that's why it says here when the denominator is a 2, okay, we think halves. Okay, so a half is 0.5, 3 and a half is 3.5, and so on. When the denominator is a 4, like these ones here, we think quarters. Okay, so 1 quarter is 0.25, 3 quarters is 0.75. Okay, now the other one we need to look at is when the denominator is 5. Denominator is 5 is easy because 3 over 5, we can simply change that to a fraction out of 10 just by doubling, and suddenly we have our decimal. Okay, so anything that involves like 5 or 50 or 500 as the denominator makes it easy, because we just double it and we'll get a denominator of 100 or 10 or 1,000, and you can write the decimal very simply, just like this one here. 17 over 50 is the same as 34 over 100. We're just doubling the numbers, so it becomes a decimal of 0.3534. Right, what about all our other fractions? Well, here's a fraction of 5/8, and the way we do 5/8 is we essentially do a division and we divide it out. Okay, now as you can see here, 5 over 8, we're basically saying how many 8s go into 5. So when we say how many 8s go into 5, obviously none of 8s go into 5 because it's bigger than 5, so we say it's 0. Okay, but if it's 0 times, it's a remainder 5, so we put the 5 in as a remainder. Then we say how many 8s go into 50. Well, 6 8s are 48, so it goes into it 6 times. So 48, take that away from 50 is 2, so we have a remainder of 2. So in the next remainder we put here on 0. So then we say 8s into 20 go twice, because 2 8s are 16. So twice with a remainder of 4. And then finally, how many 8s into 40? It goes 5 times. So the decimal becomes 0.625. Okay, let's look at another one while we're here. And let's do, well, what is 1 over 8? Okay, well, I'm going to take 8 and I'm going to divide it into 1. Now, dividing it into 1, we get 0. But we have a remainder of 1. So we put our decimal point in for our next place down, and we put a 0 in, and we put the remainder there as 1. Now, how many 8s go into 10? Well, it goes into 10 once with a remainder of 2. So we add another 0 and make that 20 because it's a remainder of 2. How many 8s into 20? Well, that goes 2 times with a remainder of 4. Put another 0 down. How many 8s go into 40? It's 5. No remainder, so our decimal is finished. So 1 over 8 equals 0.125. Alright, finally we're going to look at some special decimals, particularly when we divide them out, because they keep repeating, and we call these recurring or repeating decimals. For example, 2/3. 2/3 is in fact 0.666 recurring. It goes on forever, and I'll show you how it does that in a minute. But we don't write it as 0.6666 forever. We write it as 0.6 with a dot on the top. Okay, but let's see why it's 0.666. So 2/3. I'm going to say, well, I'm going to divide 3 into 2. Which we know doesn't go, so we put our 0, add our 0 into our next decimal place. So 3's into 2 don't go, but we have a remainder of 2, so it's 3's into 20. 3's into 20 goes 6 times. What's the remainder? 2. So we put the 2 up there. 3's into 20, again, goes 6 times. What's the remainder? The remainder is 2. So we do it again, and as you can see, because the remainder is always the same, the answer is always going to be the same with the new remainder, and it's going to continue on forever and not stop. Okay, so then we would just write it as 0.6 recurring. Now, here are some other decimals that recur. A little 13 over 11 is 1.181818. So we have two numbers that are repeating. So what we do is we put a dot above the two numbers that are recurring. Sometimes we put a straight line above it. I prefer this way, with a dot above the start and finish. Now here's a real long one. and I guess you'll be able to practice these in some of the examples, 5 over 7 is actually 0.714285714285714285. It recurs. These numbers from here to here recur. So what we do is we put a dot above the 7, a dot above the 5, and everything between those two dots is repeated.